Welcome to today's episode. We're diving into the fascinating world of shader programming and a powerful new tool called Slang, designed to help developers create high-performance shaders more efficiently. So what exactly is Slang? Well, it's a shading language specifically crafted for real-time graphics developers. Imagine trying to build an intricate structure out of Lego bricks. Each brick represents a piece of shader code. Slang helps you organize those bricks, your code, into a modular and extensible system that's not only easier to maintain, but also performs exceptionally well on modern graphics hardware. Now, what's truly exciting about Slang is its versatility. Once you write your shader code in Slang, you can run it on various platforms. It supports a plethora of targets, including Direct3D, Vulkan, Metal, and even CPU. This means you can write your shaders once and deploy them anywhere. Pretty handy, right? But wait, there's more. Have you ever faced the dread of debugging shader code? We're talking about complex language structures where you often lose track of function calls and variable names. Slang tackles this issue head-on by generating readable code. This feature retains the original identifier names and types, making it significantly easier for developers to pinpoint bugs and inefficiencies. Speaking of features, Slang has an incredible capability system that allows developers to leverage the latest GPU innovations. So if a new feature is released in Direct3D or Vulkan, you can utilize it without worrying about whether or not it's compatible with your existing codebase. Slang takes care of that during the type checking phase before generating the final code. Another standout aspect is its ability to support neural graphics through automatic differentiation. Now don't worry if that sounds a bit technical. Essentially, it means Slang can automatically manage changes in rendering code that involves complex mathematical functions, making it suitable for machine learning frameworks like PyTorch. For developers interested in integrating neural networks with graphics, Slang serves as a powerful ally. Now, let's talk about organization and scalability. Slang introduces a module system that makes it easy to organize your code into separate compilable segments. This helps in managing large code bases comfortably. You can compile different parts of your shader code independently and then link them at runtime, much like putting together pieces of a puzzle. And for those who may have previously worked with HLSL or GLSL, you'll find Slang's syntax familiar. This means you can jump right in with minimal adjustments, making it an attractive option for many developers looking to modernize their shader pipelines without starting from scratch. But how do you get started with Slang? It's simple. You can download a pre-built binary from GitHub, or even explore the Slang Playground to test your code in your browser without any installations. It's a quick and hassle-free way to dip your toes into shader programming. As we wrap up today's episode, let's reflect on the remarkable potential Slang has to streamline shader development. With its focus on modularity, portability, and up-to-date GPU feature access, Slang is positioned to become an essential tool in every graphics developer's toolkit. Before we sign off, I'd like to leave you with a thought. How do you think shader programming will evolve in the next few years as tools like Slang become more widespread? Dive into that question, and who knows, you might just inspire the next wave of graphics innovation. Thanks for tuning in. Be sure to join us next time for more insights into the cutting-edge world of technology and development. Until then, keep creating and exploring.